Okay, hi there, it's Ollie Epsom here again, and I'm in the lab number 2, which is my garage. It's a bit untidy at the moment, so you're going to have to excuse me for that. This is the first run of my latest work in progress project, which is an electric outboard motor for a small dinghy. Had some comments on the site recently. A lot of people are, going, "Oh my God, I can't believe you're doing this. What if you're at sea and this is all you have to rely on?" So I'm just going to open with clarification and say the primary means of propulsion for my dinghy is these and oars. This is really just another fun project to keep me going through the winter. So with that in mind, I'll take you through what we've got. Okay, so like any electrical system, it consists of major components, which is one, here we have a kilowatt-hour lithium-ion battery. Here we have a commercial off-the-shelf throttle unit designed for an e-bike. This is a 3-phase brushless DC motor controller. This here is a brushless 3-phase 1000 watt or 1 kilowatt motor, so it's approximately 1.25 horsepower for those imperial friends. This is a sensor controlled motor, so we see we've got 3 phases coming out of it here, and this is the Hall line for the Hall effect sensors. This is coupled, albeit crudely, this is work in progress, this is a first run, via this laser cut transition plate here to this ancient, and I mean ancient, 2 horsepower Johnson outboard that I bought on eBay, non-working, for about £14. I've ripped all the top end off it but the actual propeller end, gearbox and everything seemed sound enough, so I've basically just hijacked that. Now, I have it here in a bucket for demonstration purposes. So the first thing we're going to do now is give it a whirl. So here we are. Obviously that's only a very slight amount of power. Then to go backwards, we simply press this button. Forwards, backwards, forwards, backwards. Now, obviously if we want to go fast, we simply do this. We start building up speed. As you can see, it doesn't take long to empty the bucket. Yeah, so obviously there's a hell of a lot of work to do. This is very much just a breadboarded effort at the moment. Final system, obviously this is all going to be in an enclosure. I've got some corrosion protection work to do on the motor drive shaft. All this is stainless steel and aluminium, but the drive shaft is probably the weak point. Obviously this all needs to be enclosed. The battery is actually going to be in a separate compartment, and it's also going to incorporate 12 volt in, 12 volt out inverted, so you can actually power it or charge the battery from a 12 volt source if you want, as well as from a 240 volt source, and also you get a 12 volt out from the battery to use the dinghy pump and things of that nature, or lanterns or anything else. And then there's got to be an interface control computer that basically monitors it, controls it, gives you current, voltage and things like that. And then here there's going to be some sort of nice cover that I'll have to GRP up somehow. Not quite sure how to do that yet, but I look forward to doing it over the winter, and I will get back to you with anything. So as usual, thank you very much for watching. If you've got any comments or advice, anything else, feel free to get in touch. If not, we'll see you next time. Thank you.